In this video, we're going to talk about vector quantities. We're going to see what they are and how do we use them when modeling dynamical systems. So let's dive into it. A vector quantity is a quantity that needs two things to be specified. It needs magnitude and it needs a direction. Examples of vector quantities include velocity, acceleration, force, and torque. Note that for each of these quantities, you will need to tell what is the magnitude of this quantity and what is the direction of the quantity. To, for example, specify a force, you will need to tell what is the direction of the force being applied to a certain body. You will need to tell that with respect to some reference, and you will need to tell the magnitude of the force. Something similar applies to a velocity. You will need to tell, say, how many miles per hour you're measuring or observing, and you'll need to tell what the direction of that speed is. In contrast, a non-vector quantity does not need a direction to be specified. It will only need a magnitude. Two examples of non-vector quantities can include temperature and mass. Please note that sometimes in other fields like software engineering, you will see the word vector. And in those cases, for software engineering or computer science, what they're referring to is a collection of variables or a collection of objects. Also, in linear algebra, the concept of vectors goes beyond just this type of quantities. You might be referring to collection of more abstract objects or mathematical objects. And even in dynamical systems, you will hear the concept of state vector. The state vector is used to represent in a certain way a dynamical systems, and it also refers to a collection of objects. All of these objects referred here in the software field in linear algebra and dynamical systems do not necessarily have a magnitude in a direction that can physically represent something, but the whole idea is that a vector will contain a set of objects, or it will be a collection of objects. So how do we use these vector quantities when we're modeling the dynamical system? Well, for the cases of, say, robotics and mechanical systems and aerospace systems, we're interested in things like the position of an object, maybe the velocity of that object, forces and torques applied to that object or system. And to do that in an intuitive way, we normally draw those vectors using arrows. And each of these arrows, say the one that represents velocity, and let me just redraw that over here. So we have that system. And to make the analysis more intuitive, what we do is draw that velocity vector using this arrow, where this magnitude or this vector length is going to be representative or proportional to the magnitude of that vector. So that would be representing the magnitude. That length represents the magnitude, and the direction of that vector needs to be given with respect to something, with respect to some reference frame, with respect to some coordinate frame. And I've talked about these two concepts, reference frame and coordinate system, in previous videos. So if you didn't see them, go and watch them before and then come back to this other video. But this magnitude in this direction will be represented with respect to some coordinate frame, and we're gonna give it a little bit more details on that. But again, coming back to this example where you're representing this velocity with this arrow, you will have a magnitude which is represented with the length of this arrow, and you will have some direction for that arrow that I will represent here with this angle with respect to this dashed line, which can be any reference you choose. All right, so it will be the same with the forces and position and acceleration. You will need to have a reference frame and a coordinate system. So again, we draw these vectors, these quantities with an arrow and a direction on these diagrams to make it more intuitive for us when modeling these dynamical systems. In mechanical engineering, we might be working with a system, and let me just draw this over here. We might be working with this other system, and what we like to know is the state of that system, where the state could include what is its position and its velocity. And to do so, we will need to write some equations that will involve these vector quantities. Now, to write these equations and to represent these vectors, we will need to establish a coordinate system. In this coordinate system, which we normally picked as a system with 3 unit vectors that are perpendicular to each other, this coordinate system is fixed, and we want to represent these vector quantities, in this case position and velocity, with respect to this coordinate system. So a coordinate system, you will normally see that it looks like this. It has 3 axes that are unit axes. That means they're also vectors. They're basis vectors of of length equal to 1 or magnitude equal to 1, and they have a 90 degrees, or they're placed in a way that each axis is 90 degrees apart from away from each other. And again, you can go and watch the other video that I have on coordinate systems, so I go into more detail about that. And it is not necessary to have those properties here, but it is convenient. So coming back to this example, you need to define this coordinate system. And in the literature on the internet, you will see that normally you define this as X, Y, Z. So you label each axis to know which direction is which. And then we're going to define, in this case, the position of this object that I have here, this system. This is the system. It can be a body, it can be a satellite, it can be a rocket, it can be something, a car, a drone. So when you're going to define the position, you will need to draw that arrow. And you have that arrow, and it has a magnitude which will be representative of the magnitude, or the distance in each of the axes, and it will have some direction with respect to this axis. So that position is defined now with respect to this reference frame. With the velocity, you can do something similar. If this object is traveling, and let's just have that dot as the center of gravity of that body or system, and then I'm just going to draw the velocity vector here. So that velocity is also, again, an arrow. It has a direction, and it is defined with respect to the same coordinate system that is right here. Once you have defined your coordinate system and you have your vectors, your quantities that are vector quantities defined with respect to this coordinate system, then you're ready to start writing the equations of the system and start analyzing that system or modeling the system. All right, so let's just dive into a very quick example to see how this works.